Hey all, so in this video we're going to look at linear functions again, and this time it will be more finding the finding the equation of the function algebraically rather than from a graph. There's a few different forms we're going to see, and we've already ran into them in the last video. Slope-intercept form, that was the one that's y equals mx plus b. M is the slope that we looked at last time, and b is the y-intercept. So for graphing, we could start on b and then follow the slope up, for instance. If we know m and b, that means we know the equation of the line, which we'll do quite a lot of in this section. Standard form, we saw this when we were finding the intercepts. This is where the x and the y are on the same side. Standard form is more literally just a form that equations may be in. They're going to generally be either in slope-intercept form or standard form. For instance, this example down here, if I brought the 9 over to the side, then that equation would be in standard form. Point-slope form, we usually don't leave equations in this form, but it is a form that can help us get to one of these other two forms. And I'll show an example. Basically, when we go to find the equation of a line, we're probably either going to use point-slope form or slope-intercept. They both get us to the same spot, which is slope-intercept, but I'll show a couple of different roads of getting there and then encourage you to use the method that you prefer. For this first example, give the slope and the y-intercept of the line this. So if this was, right now it's pretty close to standard form. Like I said, if I bring over the 9, it's standard form. But from standard form, that doesn't give me either the slope or the y-intercept. So if I could make this look like that, which is to say get y by itself and simplify the right-hand side, then I could read the slope and the intercept right off of the graph, which is exactly what we're going to do. So let's start by bringing that 9 over. So I'd have 8x minus 5y equals 9. And then I want, I probably should have brought that 8x over at the same time. Sorry about that. So let me bring the 8x over as well. So that certainly could have been one step. I think I was still thinking about standard form. So there was standard form if we cared. We don't. I'm trying to get y by itself, so I would bring the 9 and the 8x over. And then we'll divide everything by -5 to finish isolating y. So those cancel, and I have y equals negative over negative would make 8/5 x, and then minus 9/5. So my slope for this one would be the value in front of x. That's always going to be our slope when we're in this form. So 8/5. And my y-intercept, or b, would equal the negative 9/5. You have to be a little bit careful on the answer in the computer on these. You probably saw it in the last section. Sometimes they want 0, -9/5. Sometimes the 0 is outside the box, and sometimes they just have b there, and then you type -9/5. So if you're getting it wrong and you're thinking you should have it right, it may be that you need to type it as ordered pair. So anytime we're given some version of an equation of a line, if we need slope and intercept, just by solving it into slope-intercept form, we can get those two values. For this next one, we're supposed to find the equation of the line with a slope of -3 and passing through this point. Write your equation in slope-intercept form. So this is where I was saying there's a couple of ways to do this. I could do, first actually let me write down what we know. We know m equals 3, and we have a point xy of 8 and 42. So we know 8, 42 would satisfy our equation. So if I think of y equals mx plus b, x and y end up being variables. The two things I need to know are the slope and the y-intercept. I do have a point here that are an xy that satisfy this equation, and I know the slope. So if you look, that means I know 1, 2, 3 of the 4 variables, which means if I plug these 3 in, I can use it to solve for the 4th. So we'll let 42 equal the y. M is 3 and x is 8 plus b. And then 42 equals 24 plus b. And so that means that b is going to equal 42 minus 24, that would be 618. So here we just have to remember to actually write down our answer. So that would be y equals m was 3 and then plus 18. So that would be one way to do this. And that's actually the way that I'll do the rest of the questions. But we had point slope back there, so let me just use this example as an opportunity to show you point slope form. And for some people, they really prefer this version of solving. It's actually just our slope equation, y minus y, x minus x, if I divide that back over, equals slope, but relabeled with x and y, so it's the same x and y as over here, they're just the variable, and then the x1, y1, that's our point. So we're given a slope and a point, we can plug into here and find our equation. So y minus 42 equals m, which is 3, and x minus 8. And so you can see this is going to end up being the exact same math as what I did over here. I just, when I solve it, I'll land on this answer rather than solving for b. So y minus 42 equals 3x minus 24. And then adding the 42 over, so again we're going 42 minus 24, same as we did over here, and we get 3x plus 18. So exact same answer, same basic steps. Some people prefer this one, some people prefer that one. Like I said, they both get you there. So I would suggest you pick the way that makes the best sense to you and then do that. Number 11 is basically number 10, but one step back. So here we're given the slope and a point. Here we're given 2 points, and then asked to find the equation line. So we know with 2 points we can find the slope, which then we'll be right back at this problem because we'll have a slope and we have 2 points to choose from. And then we just do these same steps for finding b. So for finding m, I'll just have this be my x1, y1, this be my x2, y2. So y2, negative 2 minus 22, the y1. That's over x2 is negative 1 minus a negative 5. And careful with all those signs in there. It's really easy to mix one up. Minus 2 minus 22 is going to be minus 24. And minus 1 plus 5 would be 4, because that minus and minus becomes plus. And it looks like our slope should be negative 6. And then I can use either of these points. This one has smaller numbers, so that's what I'm going to do. So there's my m, and then there's my point. And then I'll just do y equals mx plus b. Again, if you prefer point slope, do that one. So y is negative 2, m is negative 6, x is negative 1 plus b. So negative 2 equals 6 plus b, subtracting the 6 over, negative 8 equals b. And that means now that I have b and m, I can write down my answer. Y equals negative 6x and then minus 8. This next question is the same thing, except it's given in sentences instead of just here's the 2 points. Clothing business finds there's a linear relationship between the number of shirts Anna can sell and the price Pia can charge. In particular, historical data shows that 5,000 shirts can be sold for $16 and 9,000 shirts can be sold at $8. Give a linear equation in the form P equals M and B. So notice right there, P equals N, M and B. That means that N is going to be our X, our input variable, and P is going to be our output variable. So that's when they give us that, that's what we want to take from that. Sometimes they can phrase this, if they had said historical data shows that shirts sell for $16 a piece when 5,000 are manufactured, you can say the English backwards from the order that the values are supposed to be in. So it's always good to kind of stop for a second and figure out which one's my input, which one's my output. And so we're supposed to give the equation in this form and then round our slope to 3 decimal places. Okay, so let's write out our ordered pairs. So our number and our price, so they are in the right order this time, but there's nothing that says they have to be. So again, good, keep an eye out for that. And then 9,000 goes with $8. And you can see I'm basically right back at that last problem. Here's my 2 points, and now I'm just going to find the equation of the line. So for slope, careful to do y2 minus y1, even if you're thinking it'd be nice if those were the y's, but they are not. So 8 minus 16 over 9,000 minus 5,000. So that got me -8 over 4,000. And then since it told me to round the slope to 3 decimal places, I just threw that in the calculator right there and got -0.002. And now that I have a slope and a couple of points to choose from, I'll just plug those into slope-intercept form. So let's see, I write out, this case, this is P equals mn plus b, and we're solving for b. So P is our price, so I'm going to use this point. It doesn't matter which one we use. 16, m is our slope, so that's -0.002, and n is our number of shirts, that's our 5,000, plus b. If you throw that into the calculator, it comes out to -10 plus b, add the 10 over, and you get b is 26. So our equation with the right variables would be P equals m -0.002, and then n, our number of shirts, plus 26. And then these last 2 examples are going to be for parallel and perpendicular lines, and it's basically the same. We've already done all of the math to know how to do this. We just need a couple of definitions. So for parallel lines, parallel means that they're going to track each other forever, right? They never get closer or farther apart. They are parallel, so they would have the same slope. And that's exactly what this says. These 2 lines are parallel if their slopes are equal. So that would be that situation. Perpendicular is actually just like the coordinate axes, so they intersect at a 90-degree angle. That's our definition of perpendicular. And what that means in terms of the slopes is that if you multiply the 2 slopes together, they should make -1. Well, that's a perfectly fine definition. It's a little hard to use it to find perpendicular slopes, so let me give you an easier way of looking at it. If, say, the slope of our original line is 2/3, the perpendicular slope, which is that little upside down T, would be the opposite sign. That's the product of their slopes with -1. So it has to be the opposite sign and then the reciprocal of the slope. So flip the fraction, make it, instead of 2/3, it'd be 3/2 with the opposite sign. And then if you multiply 2/3 times -3/2, you get -6/6. That is that would be -1, which is what the definition says it's supposed to be. One more example with that. If our original slope was -3, just because that one can be a little tricky, remember there's an invisible 1 under there, so the perpendicular slope to that one would be +1/3. So that's how you would do parallel and perpendicular. And again, for each of these, if our original slope was 2/3, parallel would just stay 2/3. So for these couple of examples, we're give the equation of the line that goes to the point -2, 6 and is parallel to this line. So this is a lot like what we just saw on the very first question of this video, which is we're given an equation, this time in standard form, and we need to know the slope. So the easiest way to do that would be to get it in slope-intercept form. So let's bring the 3x over to this side. So that would make it a negative 3x minus 8. And then we'll divide everything by 2. So that gives us y equals negative 3 halves x minus 4. A note about this 4, you don't care about it at all. This point right here is what you care about, because now you know your slope is negative 3 halves. If we're finding a line parallel to that, our slope is also going to be negative 3 halves, and we're using with this point. Most common thing I see people do wrong on exams is then try to somehow incorporate that negative 4, which doesn't have anything to do with the problem. All this is doing is giving you slope. So we'll pop up here and go y equals mx plus b, and let's see, y is 6, m is negative 3 halves, and x is a merciful negative 2 right there, so we're not going to have to do fractions, because these are just going to cancel each other, and negative 3 would be 3, so that would be 6 equals 3 plus b, and then moving the 3 over, looks like b should be 3. Just double check myself here. Cool. So y equals negative 3 halves x plus 3. For the last example, it's the exact same stuff. It's still this equation and that point, but now instead of the slope being parallel, so where it would be the same slope when we go to solve, it's going to be perpendicular. And so our slope that we found was negative 3 halves, so our m perpendicular is going to be positive 2/3. I'll just copy that point down so I have it when I scroll up. So there's our perpendicular slope at our point, and I think this one turns into a few fractions, but it's still the same exact math. So y is 6, m is 2/3, x is negative 2 plus b. So remember, negative 2 is the same thing as negative 2 over 1, so it's the numerators multiply and the denominators multiply. So that would make negative 4/3 plus b. And then I will add the 4/3 over to this side. I'll pop up here with it. 6 plus 4/3 equals b. And then in order to add these two together, I need to have a common denominator. So I need the 6, instead of being a 1, I need it to be a 3. So we're going to multiply by 3 over 3, because that's going to get my denominator to be 3 with an equivalent fraction. So 18 over 3, not a very good 8. Oops, messed up there. So 18/3 plus 4/3 equals b, 18 and 4, and that would be 22/3 would be b. So y equals our slope 2/3 x plus 22 over 3. So basically, for finding the equation of a line, the two things you're going to need are a point and a slope. And there's a lot of different ways they can give you the slope. They could just tell you, like the first example. They could give you 2 points and make you solve for it, like the second example. If you're given a graph, you could read the slope off of the graph. Or here, if you're given another line and said parallel or perpendicular, you can find its slope and then get the slope that way. So the prompts can be a little bit different, but all of them, your first step is to find the slope and then to put it with the point to find the y-intercept. And that's basically how every problem we just did worked, just a little bit different prompts with the same math.